See the first question. The general theory of relativity talks about both inertial and non-inertial frames. If you concentrate on special theory, that talks about only the inertial frames, whereas the general theory is dealing with both inertial and non-inertial frames. The unaccelerated frame is called inertial frame. The special theory of relativity deals with only inertial frames. See the fourth question. Which one of the following points is incorrect? See the point C. The laws of physics are not the same for all observers. This is incorrect because the laws of physics are the same for all observers in the inertial frames. According to special theory of relativity, the laws of physics are the same in only inertial frames. According to the special theory of relativity, the velocity of light in free space is the same in only inertial frames. See, the Galilean transformation equations are x dash equal to x minus vt, y dash equal to y, z dash equal to z, t dash equal to t. So all the above is the correct answer. The Galilean inverse transformation equations are x equal to x dash plus vt dash, y equal to y dash, z equal to z dash, t equal to t dash. So all the above is the correct answer. In the Galilean transformation, velocity is transformed, acceleration is invariant, velocity is transformed but there is no change in acceleration. None of the above. Option C is correct because x dash equal to x minus vt is our Galilean transformation equation. If you make the differentiation with respect to time, we can get u dash equal to u minus v. Here the velocity is transformed. In this case, the frame is moving with the constant velocity, so here v is a constant. If you differentiate once again, you may get du dash by dt dash equal to du by dt, because dv by dt equal to 0, since the frame is moving with the constant velocity. So u dash equal to a. Therefore, in Galilean transformation, velocity is transformed, but acceleration is invariant. Therefore, option C is correct. X dash equal to x minus vt divided by root of 1 minus v square by c square, y dash equal to y, z dash equal to z, t dash equal to t minus v by c square into x whole divided by root of 1 minus v square by c square are called Lorentz transformation equations. So all the above is a correct answer. The inverse Lorentz transformation equations are x equal to beta into x dash plus vt dash, y equal to y dash, z equal to z dash, t equal to beta into t dash plus v by c square into x dash. Therefore, all the above is the correct answer. The concept of length contraction is, we know that L equal to L naught into root of 1 minus v square by c square. Here L naught is the length of the rod measured by the observer in motion. L is the length of the rod measured by the observer at rest, whereas L naught is the proper length. So, we may say the length of the rod measured by an observer at rest is contracted by the factor root of 1 minus v square by c square as the length measured by the moving observer. The length of the rod as measured by an observer who is at rest with respect to the rod is known as proper length. See, the frames are S and S dash. Here, this is S frame, O is observer. This is S dash frame. Here the rod is present. S frame is at rest, S dash frame is in motion. Here the length predicted by the observer O dash is L naught. With respect to the rod, the observer O dash is at rest, O is in motion. Therefore, L naught is the proper length. In the following statement, which one is true? When V is very small compared to C, then L equal to L naught. This statement is true because in this expression, V is far lesser than C, then V square by C square term is negligible. So L equal to L naught. The same is true for Lorentz transformation equation also. In Lorentz transformation equation, x dash equal x minus Vt divided by root of 1 minus V square by C square. If V is far lesser than C, you may neglect this term V square by C square. Therefore, the Lorentz transformation is reduced into Galilean. In the Michelson experiment, the reason for no shift in the fringes is due to the paths traveled by the reflected and transmitted beams take the same time. There will be no phase difference between the reflected and transmitted beams. So the options A and B are correct. So the correct answer is option C. See the 16th question. A rod has a length of 100 centimeter. When the rod is in a satellite moving with a velocity that is 1/2 of the velocity of light, that is V equal to 0.5 c, related to the laboratory, what is the length of the rod as measured by an observer in the satellite and in the lab? For the observer in the satellite, the length of the rod is 100 centimeter because that is proper length. For the observer in the laboratory, the length is contracted. The contracted length is 86.6 centimeter. Using this formula, we can get it. See the 17th question. Calculate the percentage of contraction in the length of the rod moving with a speed of 0.8 c in a direction at an angle of 60 degree with its own length. This is system S. This is S dash system. Let the length of the rod in the system S is L. Here S dash is another one frame moving with a velocity 0.8 c at an angle 60 degree with x-axis. Therefore, the new length L dash equal to root of Lx dash square plus Ly dash square. Here the value of Lx dash is L cos theta, that means L cos 60 degree, because theta value is 60 degree, into root of 1 minus V square by C square. If you simplify this, you may get the value of 0.3 into L, because cos 60 is 1 by 2. There is no motion along a direction perpendicular to Ox dash. Therefore, Ly dash is equal to L sin 60 degree. But in Lx dash, we have added another one term, that is root of 1 minus V square by C square. But in Ly dash, we cannot include the term root of 1 minus V square by C square because there is no motion along that direction. Therefore, Ly dash is equal to L sin 60 degree, which is L into root 3 by 2. Sin 60 degree is root 3 divided by 2. You substitute these two values, you can get the L dash value as 0.87 L. Percentage contraction is equal to L minus L dash divided by L into 100, that is 13%. The concept of time dilation is T equal to T0 divided by root of 1 minus C square by C square. T is time predicted by the two successive events, that is time interval predicted by an observer at rest between the two successive events. T0 is the time interval recorded by the observer in motion. For the rest observer, the time interval is longer, which means that the rest clock goes faster than that of the moving clock. According to the concept of time dilation, the stationary clock measures longer time interval than the moving clock. According to the concept of time dilation, the stationary clock runs faster than that of the moving clock. in the above problem, when v is very small compared to c, then v square by c square term is negligible, so t equal to t0. When v is comparable to c, velocity is 0.8 c, like that. At that moment, we may say the velocity of the frame is appreciable to velocity of light. V square by c square is having some value. At that time, t is greater than t0. When v is equal to c, here if you put c square instead of v square, c square by c square is 1 minus 1, 0, anything by 0, infinity. So t is infinity. When v is greater than c, in this expression, if you put v is greater than c, this term is expressed in terms of minus sign. You may get the negative result. You know that I square is minus 1. Therefore, inside the root we can get I square. If you take it out, we can get I. So the time is imaginary here. When v is greater than c, the time is imaginary. The concept of proper time represents the time interval recorded by an observer who is at rest with respect to the clock. A particle with a mean proper lifetime of 2 microseconds moves through the laboratory with a speed of 0.9 c. Calculate its lifetime as measured by an observer in the lab. Here t0 equal to 2 into 10 power minus 6 second. Micro means 10 power minus 6. Then velocity equal to 0.9 into c. We substitute all these values, we can get t equal to 4.59 microsecond. The concept of addition of velocities is u equal to u dash plus v divided by 1 plus u dash v by c square. When u dash and v are smaller as compared to c, see the concept, u dash and v are smaller as compared to c, then u equal to u dash plus v. Because u dash is smaller, v is also smaller, this term is neglected, so we may get u equal to u dash plus v. When u dash or v equal to c, see that in this expression, instead of v, if you put c, u dash plus c whole divided by 1 plus u dash c divided by c square, which is equal to u dash plus c whole divided by c plus u dash whole divided by c, which is equal to u dash plus c divided by u dash plus c into c, which is equal to c. So option C is correct. The addition of velocity of light to the velocity of light reproduces velocity of light greater than the velocity of light, less than the velocity of light. That means c plus c equal to c, not to c. If you add anything to the velocity of light, the result is velocity of light. Two particles came towards each other with the speed 0.8 c with respect to laboratory. What is their relative speed? Here u dash equal to v equal to 0.8 into c. Then u equal to u dash plus v divided by 1 plus u dash v by c square. Then substitute the values, we can get u equal to 0.975 c. According to Newtonian mechanics, mass of a body does not change with velocity. According to Newtonian, because we may say force equal to rate of change of momentum, some constant, or we may write force is directly proportional. By keeping mass as a constant, we are differentiating only the velocity. F is proportional to m into a, here m as a constant. To remove the propel design, we have introduced a constant whose value is unity, so F is equal to ma. So according to Newtonian mechanics, mass of the body does not change with time. The concept of variation of mass velocity is m equal to m0 divided by root of 1 minus v square by c square. When v is comparable to c here, then m is greater than m0, m is less than m0, m is equal to m0, m greater than or equal to m0. Here v is comparable to c, m is greater than m0. When v is equal to c, the mass is infinity. When v is greater than c, m is imaginary. At what speed the mass of an object will be doubled of its value at rest? Here the condition is m equal to 2m0. What should be the value of v? In this relation, instead of m, we have to put 2m0. So 1 minus v square by c square inside the root is m0 divided by 2m0. Now this is equal to 1 by 2. On squaring, we can get 1 minus v square by c square is 1 by 4. Then if you simplify this, you can get 2.6 10 power 8 meter per second. So the option A is correct. The rest mass of an electron is 9.1 10 power minus 28 gram. What will be its mass if it are moving with 4 by 6 the speed of light? V equal to 4 by 6 into c, that is 0.8 into c. m0 rest mass is 9.1 10 power minus 28 gram. If it is expressed in terms of kilogram, 9.1 10 power minus 31 kilogram. Now substitute m0 v, you may get m equal to 9.1 10 power minus 28 divided by 1 minus 0.8 c divided by c whole square inside the root. If we simplify this, we can get 15.16 into 10 power minus 28 gram. So option A is correct. According to the theory of relativity, the mass as well as velocity are variables. Total energy of a moving particle is the sum of its kinetic energy of motion and energy at rest. Option B, E equal to c square into m minus m0 plus m0 c square. Option C, both A and B. Both A and B. This is a mathematical version of point A. Therefore, the correct answer is both A and B. The consequence of mass energy equivalence is pair production and pair annihilation. Therefore, the answer is both A and B. In pair production, mass is converted into energy, energy is converted into mass. Option B is correct. Suppose an electromagnetic radiation is approaching a charged nucleus, a particle, say electron, and its antiparticle, positron, are generated. Here, energy is converted into mass. During pair annihilation, energy is converted into mass or mass is converted into energy. Here, option A is correct. Suppose an electron meets its antiparticle, positron, they annihilate. So energy is liberated. So mass is converted into energy. In general, E equal to mc square is the equation. That is the fractional increase of mass of a particle for velocity 0.1 into c. You know that m equal to m0 divided by root of 1 minus c square by c square. M by m naught equal to 1 divided by root of 1 minus c square by c square. V equal to 0.1 into c. Therefore, m by m naught equal to 1 minus 0.01. This is modified as 1 minus 0.01 power minus of. This is 1 plus 0.01 by 2. That is 0.005. Then m by m naught minus 1 is equal to 0.005. Therefore, m minus m naught whole divided by m naught equal to 0.005. This is the fractional increase of mass. A reference frame. The answer is 0.005. A reference frame attached to the earth is an inertial frame. Einstein mass energy relation E equal to mc square shows that mass disappears to reappear as energy, energy disappears to reappear as mass. Mass and energy are two different forms of the same entity. All the above are correct. Option D. All the above are correct. When 1 gram of mass is converted into energy, the amount of energy released in kilowatt hour is, see this equation, E equal to mc square, where 1 gram is converted into 1 kilogram, that is 10 power minus 3, 3 into 10 power 8 square. This is the value of c square, which is equal to 9 into 10 power 13 joule. 1 kilowatt hour equal to this much joule. Therefore, E equal to 9 into 10 power 13 divided by 36 into 10 power minus 5. See, this is 10 power 5. If you bring this to the numerator, 10 power minus 5. So the answer is 0.25 into 10 power 8 kilowatt hour. So the option B is correct. The sun radiates energy at the rate of 3.6 into 10 power 33 x per second, which is equivalent to an annihilation of mass at the rate of 4 into 10 power 12 gram per second. You know that T equal to mc square. Here the energy is given in terms of here 3.6 10 power 33 x per second. M into here the velocity c equal to 3 into 10 power 8, but we have to express in terms of centimeter because energy is expressed in terms of x per second. So that if you simplify this, you may get the m value in terms of 4 into 10 power 12 gram per second.